Right, let's look at our equations and the answers to our exercises, starting with linear equations. Right, let's look at A. In a linear equation, I find it easier to find a lowest common denominator if they are fractions, which here they are, and to multiply by this lowest common denominator to every term. Now, in this case, our denominators are 6a, 4, and 3a, which means our lowest common denominator is 24 would be a number that 6 and 4 and 9 and 3 could go into, but even lower than that, I could use 12. 6 and 4 and 3 could both go into 12, and I'll need an A. Which means, what that means is I'm going to take each of these terms and multiply by that lowest common denominator. The thing in equations is, as long as you do the same thing to everything, same thing to both sides, you're not breaking any rules. So I'm going to take each one of those terms and multiply by 12a. Now, why this works out nicely is that a goes into a and 6 goes into 12 twice. So that entire term simplifies to 5 times 2, which is 10. 4 goes into 12 3 times, so my second term here simplifies to minus 3a. On the right-hand side, I've got 12a. A goes into a once, 3 goes into 12 4 times, and I have minus 8. So what looked like a nasty equation is simplified quite nicely by multiplying out by my lowest common denominator. Now I have a linear equation, which means all my letters to one side and all my numbers to the other side. Now, most people are more comfortable with getting our letters to this side. So I'm going to get rid of 12a, so I'm going to minus 12a from this side, and I'm going to minus 12a from that side. You must do the same thing to both sides. So now I get 10 minus 15a is equal to negative 8. Now I need to get rid of my 10, so I'm going to minus 10 on both sides, which leaves me with minus 15a is equal to minus 18. Now, obviously, I need to divide by negative 15 to get a by itself. Now, if you don't like fractions, pick up your calculator and go negative 18 divided by negative 15. Obviously, my negatives cancel, and 15 and 8 both have common factors. So they both have a common factor of 3, so it'll simplify to 6 over 5, because 3 goes into 18 6 times, and 3 goes into 15 5 times. But use your calculator to check that you're right. Great, let's look at B. Again, it has a denominators, which means that I need to figure out a lowest common denominator and multiply by it. Now, this 2 minus x, we've seen this before in our algebraic fractions. I know that I can change 2 minus x to x minus 2 simply by changing the sign in front of the fraction. Now, will this be any simpler if this is x minus 2? Well, not really. I don't see any other x minus 2's that it needs to be like. So in this case, I'm not going to even bother. Swapping that around is not going to help me. Now, lowest common denominator clearly has to have an x. It needs to have an x plus 2. And it needs to have a 2 minus x. Which means I'm going to multiply each one of these terms by my lowest common denominator. So I'm going to multiply it by x plus 2, 2 minus x. I'm going to multiply my second term by exactly the same denominator, x plus 2, 2 minus x. And as long as I do the same thing to everything, I haven't broken any rules. Now I'm going to run out of space here. I'm going to just write at the top. Great, now why this is super is that x plus 2 and x plus 2 cancels, which leaves me with 5x and 2 minus x, plus 2 minus x and 2 minus x cancels, which leaves me with 3x, x plus 2, which equals x and x cancels, so I'm left with 2x plus 2, 2 minus x. Now this doesn't look particularly linear. This looks like it might end up being a quadratic. Well, let's check. Either way, I need to multiply out in collective like terms. So 10x minus 5x squared plus 3x squared plus 6x equals 2. This will be 2x minus x squared plus 4 and minus 2x. So there's clearly some simplifying there. Let's try to simplify this left-hand side. Minus 5x squared and 3x squared will give us minus 2x squared. 10x, and 6x gives me 16x. Now on this side, immediately I can see the 2x minus 2x in my bracket are actually going to cancel. So all I'm left with here is a minus 2x squared and a plus 8. Now why this is going to remain linear is have a look what I've got here. I've got minus 2x squared and minus 2x squared. So I've got the same thing on both sides. Now, I'm generally trying to get my x's to one side. So if I plus 2x squared to this side to get rid of it, and I plus 2x squared to this side, they actually cancel on both sides. So this is in fact linear, and I'm left with 16x is equal to 8. Divide by 16 on both sides. And simplified, please always simplest form, I get x is equal to a half. So my minus 2x squared plus 2x squared cancelled on both sides, and so this was in fact linear and not quadratic. Right, let's carry on one last one. This one looks like some of the denominators can easily be factorized before we build our lowest common denominator. And if I look at this closely, 3 minus k, maybe I should change that around to k minus 3 by changing the sign in front. But we'll see. Let's start. So k squared minus 9 is clearly difference of two squares, k plus 3, k minus 3, which immediately confirms my suspicion that 3 minus k would be more usefully written as k minus 3. So this will be k minus 3 is fine, equals 6 over 1. And I'm going to change this to minus k over, and then I can change it around to k minus 3. And I want to do that, so my lowest common denominator is simply k minus 3 and k plus 3. Now all I need to do is exactly what I've been doing so far. Multiply each term by this lowest common denominator. So k minus 3, k plus 3, k minus 3, k plus 3, k minus 3, k plus 3, k minus 3, k plus 3. Now in an exam, I never would have written this out like this because, you know, what is this doing? Is it an exponent? But I'm doing an exercise, so I'm not writing out neatly. In an exam, I wouldn't write it out like this. I would rewrite a whole line, leaving more space. Now, k minus 3 cancels, k plus 3 cancels, so that term is left with 7k. K minus 3 cancels, so I've got 5k and k plus 3. This one, nothing cancels, so I've got k minus 3, k plus 3, and k minus 3 cancels, so I've got minus k, k plus 3. Now this looks very similar to my previous example. Could be quadratic. Let's multiply out and collect it like terms. So 7k plus 5k squared plus 15k equals 6k squared plus 3k minus 3k, which I expected, and minus 9. And this is minus k squared and minus 3k. So like terms on both sides. This side so far is 5k squared plus 22k. This side will be 6k squared. Now 3k minus 3k cancels, so I'm just left with minus 54 and a minus a k squared minus 3k. Now we still have like terms on the one side, so let me keep on going. 22k equals 6k squared minus k squared gives me 5k squared minus 54 minus 3k. Now again, this isn't going to be quadratic because there's 5k squared and 5k squared, but if I minus 5k squareds on both sides, they're both going to disappear. So I'm going to minus 5k squareds on both sides, and I get 22k is 5k squared minus 54 minus 3k. Oh, sorry, no, I just said that that would disappear, so that's clearly not there. So k's to one side plus 3k to both sides plus 3k, and I'm left with 25k equals negative 54, and I'm going to divide by 25 on both sides. Now I'd use my calculator if I want to check whether negative 54 over 25 simplifies anymore. So I plug it into my calculator and it doesn't simplify. So I'm going to leave my answer as negative 54 over 25. Now in an exam, we often get to this type of answer and we think we've done something wrong. Don't panic. Often equations work out and the answers are fractions and they're not particularly nice. What I would do is leave this question and come back to it after a while and make sure to redo it and check your working if you have time in the exams. Go and find lots of these to practice because linear equations seem easy, but these denominators can make them seem a bit tricky.